Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all to the next session on the subject of system programming with Linux. The title of today's session is Unix Make Utility. And here is the agenda of today's session. After giving you an introduction to the Make utility, I will discuss the structure of a Makefile. Then we will move on to our Linux terminal and we'll practically see how Make works. We'll talk about multiple targets to Make and also see an example showing how large projects distribute the task of compiling and linking of the source files in multiple Makefiles. We will close by extending the same example and make the use of macros in the Makefile. Well, imagine you write a program and divide it into 100.c files and some associated header files. To make the executable of your source code, you need to compile those 100 source files to create 100 relocatable object files. And then you need to link those object files to create the final executable. And in case if you make a bit change in any one of the source files, you may need to recompile all the files and link all of them. Or you may like to recompile only that file which has changed and then of course relink. Unix Make utility is a powerful tool that allows you to manage compilation of multiple modules into an executable. It actually reads a specification file that is called Makefile, which describes how the modules of a software depend on each other. If you want to use a non-standard name other than Makefile with a small m or capital M, you can always specify that name to the Make utility using -f option. Make utility uses this dependency specification in the Makefile and the time when various components are actually modified, and thus it minimizes the amount of recompilation. This slide shows you the structure of a Makefile. Every Makefile actually is comprised of a lot of rules, and over here you can see one of such rule, the format of such a rule. This is the target, that is the name of the executable you want to build. And after that you need to put a colon and a space separated list of all the source files on which this target depends. The next line actually contains a tab followed by the command that will use these dependent files to create this target. Well, the main advantage of a Make utility is it makes management of large software projects easy, and you don't need to recompile a source file that has not been modified. It automatically compiles only those files that has been changed and then link all the relocatable object files. Let's move on to the Linux terminal and try to understand a simple hello world example on Make utility. Okay, we have a basic hello.c file and I have written the corresponding make file as well. Well, dear students, there are chances that this make utility is not bundled with your Linux distribution. You can check that out using which make. In my case, it is already installed and is there in the usr bin directory. And of course, the path of this make is there in my path variable. And the version that right now I'm using is 4.1 In your case, if it is not installed, you can always do sudo apt get install make. Okay, let me show you the program hello.c. It's a very basic program, printing a single line that says welcome to Linux learning make utility. Let me see the make file. Well, this make file contains only two rules. This is the first target, which is my.exe, which depends on hello.o, and this is a command that makes use of this dependency file and creates this target. This is a second rule, and this rule, the target is hello.o and the dependent file is hello.c, and it uses this command that creates this hello.o file. Well, this target is usually the name of a file that is generated by a program, mostly GCC. It is mostly either an executable or a relocatable object file. Let me do make. You see it executes both these commands and has created both these target files. If I do ls, you can see hello.o and my.exe has been created. Let me execute my.exe. It successfully executes. And let me run make again. And if I run make again, make says that my.exe is up to date. No compilation is done. Let us make a change in our source file. Let me put a full stop over here. Let me clear screen, do make again, and you see the relocatable object is created again and the file is again linked. And if I do make again, it says my.exe is up to date. So how this happens? Well, dear students, you all know that every file on your system has three types of timestamps associated with them: the access, modify, and the status change time. Let me do stat hello.c, and you can see this hello.c file has the access time, the modification time, and the change time. Well, access time is the time it is last read. Modify time is the time when its data has been changed, and this change is the status change time, if its ownership has changed. Let me do stat hello.o as well. If you concentrate on the modification time is 11:30:47 and the modification time is 11:30:51. So this says that hello.o has been created after hello.c has been modified. So that's why when we do make, it says my.exe is up to date. If I do, let's suppose, touch hello.c and do stat hello.c and stat hello.o. Now you see the modified time of hello.c is 11:32:22, while the modified time of hello.o is 11:30:51. So this says that the hello.o is older than hello.c. Hello.c has been modified. So now make will easily understand that it needs to recompile hello.c to make hello.o. So this is how make works. That is, if the modification time of hello.o is older than hello.c, make recompiles hello.c and then of course relinks. Well, dear students, Now that you have a bit of idea as to how make utility works, let us repeat this concept on another example, example 2. And this is a multi-module program in which you can see there are about 5.c files and a header file. Let us see their contents first. Let's see mymath.h. So this is the header file which contains a prototype of 4 functions. Let me see myadd.c, my sub.c, my div.c, and my mul.c. All these files contains the definition of the 4 functions which are there in mymath.h. Let me cat prog1.c as well. This is the driver program which is using these 4 functions, and it is including the mymath.h. This is the same program which we have used in creating the static and dynamic libraries in our previous session. Let's see the makefile for this as well. Okay. Well, this is the first rule, which says that myexe depends on these .o files, and this is the command which is creating this target, that is myexe, using these .o files. And then we have further rules, and each rule is creating a target using this dependent file. And finally, over here you are seeing that I am compiling my driver program, and I'm including my math.h over here, and over here -i dot is specifying the path of that header file where it is located. And since it is not located in the standard location, that is @c, that is usr include, it is present in the present working directory, so I'm using -i dot over here. Let me do make. Okay, so once you run make, it tries to create the first target, that is myexe. And since these dependent files are not there, so it will first try to create my sub.o. You see gcc-c my sub.c, which will create my sub.o. Then it will try to create prog1.o over here. Then myadd.o over here. And finally my mul.o. After it has used all these rules to create the dependent files for myexe, it will execute this command that will link all the .o files and create the final executable. If I do ls, you can see all the files have been created. Remember, the sequence of execution of commands which are shown over here, they are executed in the order in which they are written in the dependency list of the first rule. If I do make again, you can see it says myexe is up to date. Let me do touch my mul.c. By touching my mul.c, I'm just changing the timestamps of my mul.c. If I do make again, it will just compile my mul.c and it will link. It will not compile all the other files. Let me do make again. It says myexe is up to date. Let me touch my math.h. If you change the contents of a header file, only those files will be recompiled which includes this header file. Let me do make. You see, since only prog1.c is including this mymath.h, so only that file is compiled, and of course the entire program is linked. If I do make again, it says myexe is up to date. Let me run it. It says enter the first number. Let's suppose it is 7. Enter the second number. Let's suppose it is 3. And it displays the sum, difference, product, and the division of the two numbers. Okay, dear students, let's move back onto the slides and discuss a bit about the targets to make. Well, first of all, options. You can pass options to make. Uh, the most common option that we pass is -f. Actually, by default, make looks for a file, make file with a lower m or a capital M in the current working directory. And if these two doesn't exist, make returns an error. To tell make to use a different file name, you can use the -f option. Similarly, -n can be used to tell make to print out what it would do without actually doing it. And -k actually tells make to keep going when an error is found, rather than stopping as soon as the first problem is detected. This is normally used to find out in one go which source files actually failed to compile. Okay, dear students, a makefile can have multiple targets. We can call a makefile with the name of a particular target. To tell make to build a particular target, you can pass the target name to make as a parameter or a command line argument. If you don't, make will try to make the first target listed in the makefile, as we have seen in the previous example. Many programmers specify all as the first target in the makefile and then list the other targets as being dependencies for all. We will soon see this. Well, a makefile can also have phony targets. A phony target is a target without any dependency. Some important phony targets are clean, all, and install. Clean target is used to actually delete all the intermediate files that you have created while doing the compilation. You can see this hyphen and @ sign that are used before this command. Hyphen and @ sign are special characters used in a makefile. You use hyphen if you want make to ignore any error while executing a command. Similarly, you can use @ sign or this character before a command if you want to tell make not to print the command on stdout while executing that command. Okay, let us move on to the terminal and practically see these concepts. Let me clear screen. Let me move on to another example, that is example 3. Let me do ls. This is the same example, the same .c and .h files. Let me show you the make file now. Okay. So this is the make file. If you see this make file, it is same as in the previous example, but over here we have 3 more targets: the clean, install, and the uninstall target. Well, as I have already said that the target is actually the name of a file, but here you can see the target can also be the name of the action you need to carry out. Well, this clean and uninstall are phony targets as they do not have any dependency. You can see we don't have any dependency for clean and we don't have any dependency for uninstall. So these are known as phony targets. This clean is used to delete all the intermediate files that are normally created by running make. This uninstall is used to uninstall, removes files, and this install target is used to copy the executable and maybe the other required files to appropriate directories. Here we are just copying it to usr bin directory and setting its permissions. Let me clear screen. Let me do make. You can see it has performed the make. Let me do ls. It has created all the files. Let me do make clean. So this will delete all the .o files. You can see the .o files have been deleted, and I can execute myexe 5.2 here. Let me install it. Make install. It says permission denied because while copying to USR bin, being Arif, I don't have permission to copy this file in this directory. So let me be sudo for this. So my exe is successfully installed in USR bin. If I do ls USR bin and let me grep my exe, you can see the file is there. If I run my exe, so it will run successfully. You can note that I have not used / over here because the path of USR bin directory is there in the path variable of my shell environment. Okay, so let me uninstall it, make uninstall. It again says that you are not allowed to do an uninstallation. Let me be sudo for this. And now let me do my exe. It will say no such file or directory. Okay, dear students, so this is all about the basics of Make. Let me move back to the slides and move ahead and talk about multiple make files in a project. Well, dear students, there may be bigger software applications whose source is divided into multiple directories. There can be multiple developers involved in writing the code, and maybe there are multiple make files, and each make file is responsible for the compilation of a portion of the software. In such a scenario, the top level makefile can use the include directive to suspend the reading of the current makefile and read one or more other makefiles before continuing. Let us again move on to the Linux terminal and try understanding this concept practically. Let me go on to example 4. Let me clear screen. Let me ls. Okay, let me do tree. Okay, fine. Well, this is an extension of the same example program. Over here we have another developer who has written some additional source files and have kept them in this directory d1. Let us see this portion. Cat mymod.h. So, oops, okay, so it is there in d1. So this contains the signature of the function mymod, and let me cat mymod.c, which contains the definition, and let me cat the makefile as well, which that developer has created. You see it is a very basic makefile for which the target is mymod.o, which depends on mymod.c, and this is the command that is used to create this file. Let me clear screen. Let me do ls again, and let me cat the actual makefile, the makefile that is there for the root. Okay, so over here you can see there is a bit of change in this rule. Well, this rule says that this is the target and it depends on these relocatable object files. And over here we have added this mymod.o, and in the compilation command of GCC we have also added this mymod.o. In the program 1.o over here, you can see that I have added this header file and I have included it as well. And finally, this is the actual line which makes the difference. Once the makefile comes on to this line, this include directive says that halt the execution of this makefile and execute the makefile that is there in the d1 directory. So let me do it. Let me do make. You can see over here, this is the command that has been executed because of the include directive. And if I do ls, you can see all the intermediate file as well as the final executable has been created. If I do tree, you can see inside d1 this mod.o has also been created. And finally, this is the my executable file. Let me execute this. with a value of suppose 9 and 2. So this is the result. You can see this mod has also been used in a driver program this time. Okay, so far so good. Right, dear students, let us move on to the slides again. And the final thing which I want to touch upon is the use of macros in a file. Well, dear students, a Makefile allows us to use macros or variables so that we can write it in a more generalized form. Variables allow a text string to be defined once and substituted in multiple places later. Inside the Makefile, we can define a macro using this syntax. Macro name is equal to value. And later we can use it using this dollar and the parenthesis syntax. For example, we can use a macro to give options to the compiler. For example, while an application is being developed, it will be compiled with no optimization but with debugging information included. So we can have a macro C flags, that is compilation flags, to set like this. Standard is C11, optimization is 0, that is no optimization. Add the debugging symbols, and -val is the option that is used to show all possible warnings as well. And later you can use this C flag macro in the command like this. It's quite elegant. Okay, so let us move on to the terminal again. Move on to the example, that is EX5, and let me do ls, or let me do tree. So once again, this is the exact same program with no change other than the use of macros in the Makefile. So let me cat Makefile, or let me vim Makefile this time. Okay. This line, the first line on which my cursor is on, it is a convention to have the first target name as all. And well, this all depends on the target myexe, which is created over here. So this is the first macro, cc is equal to gcc. This macro is used to specify the compiler to use. If you want to use a different compiler, you just need to change this line, and the entire file doesn't need to be changed. This is the compilation flags macro. This is the include macro, which tells the location of the include files. This is the libs macro, which mention the libraries to be linked. And finally, this objs, object files. This macro lists all the object files that are there in our application program, and this is the location of the install directory. Over here you can see this myexe depends on this object files, and once it executes, all these object files are placed over here, and the command is we are going to use this compiler, and this variable will be replaced with gcc. And similarly, over here we have the object files, and over here we have the libraries, which are -lc. Similarly, all these are self-explanatory. Okay, let me move down. Okay, this is the same. We have removed all the object files in the clean target. Well, in the install target, which of course depends upon myexe, I have used a simple if statement to check if the installed directory is actually a directory and it exists. Only then the final executable should be copied over there. The backslash that I have used is just to extend a command on multiple lines, and the double ampersand is the logical and that is used to ensure that if the previous command is a success, only then the next command should be executed. And rest everything is same as we have done before. Let me quit. Let me do make. Okay, it has done it. Let me do make install. Let me do sudo. So it is going to install make, and then finally you can uninstall it and you can clean the target. Let me move back again and let me move ahead with this. We have certain special internal macros you can use in your Makefile. I'm leaving this as an assignment, and okay, we are done. Okay, dear students, now that you have a fair idea of how to write a Makefile for your application program and how to use the Make utility, you are equipped to take on the next session, in which we are going to use the tools like AutoConf and CMake to automate the build process of more complex softwares. So that is all for today's session. If you have liked it, please subscribe my YouTube channel and share it with your friends. Wish you all the best. Happy learning and Allah Hafiz.